Now for installing the DRO on the X-axis. Well, first of all, please forgive the state of my workshop. It's covered in swarf. I find it very, very difficult when you've got a machine out to be working on, out of its normal place. It's very difficult to maintain any kind of order because everything's got a knock-on effect. I'm also in the middle of this plus another project, so I'm going to have a damn good clean-up once I get this all sorted. But for now, let's just live with it. So this is the back of the table, and you can probably see there's a little screw hole there. It's 3, I think, yeah, and there's one the same at the other end, and that's it. But there's already tapped holes, so I'm not going to spend my time reinventing the wheel. I've got this piece of 10 by 20mm aluminium bar, and I've put some layout fluid on one end of it, and I'm going to put a transfer screw into that hole, find the location, and then drill a clearance hole so that I can fix one end of the bar to the table, and then the other end will be done likewise with a transfer screw at that end too. So that's what I'm going to do first. Those of you who don't know transfer screws, this might not be any help to you whatsoever, because this is very tiny and the camera might not want to focus. No, it looks okay. So basically what you've got is a little screw. It looks like a little grub screw, threaded. We're losing focus now. Anyway, the idea is that it's a threaded short screw like a grub screw, and you screw it in using this this tool. You screw it in, and it has a tiny point on the external end, and that protrudes to whatever degree you want it. You just screw it in however deeply you want, and then you can tap your workpiece, and the point on the screw leaves a little punch mark on the workpiece. You can then take the screw back out again, having done its job. Hope that makes sense. Now, this isn't great actually, because you might just see the transfer screw, just tiny little thing sticking out there with a point. That's the idea, but it won't go in any further, so the tapped hole's pretty shallow, and I'm not going to really be able to get the transfer screw in far enough, but I think I'll try to use it anyway to mark this end. If it doesn't work well, okay, then I'll try something else. Actually, that wasn't too bad. I did manage to get a little punch mark there that I can definitely feel with my scriber, so it'll be quite easy for me to make that into a reasonable basis for drilling a hole. Now, just opening up a bit more with my automatic center punch. And then I'll use a center punch with a hammer to make it a bit bigger still, and then drill it out, M3, 3mm. So I'm just using a center drill to find the position of this hole. I don't need to, there's no room for a wiggler given the height of this vise and this mill, and it's not super critical anyway because there's plenty of adjustment in the DRO itself. There's slots for the screw, so it's movable once you've got it in situ. But I don't think it's going to be a problem at all, and I think I'll be able to be accurate enough with this so that it looks fine as well. It's being functional. So center drill and then drill for 3mm, and then countersink it for the screws. And by the way, I used my height gauge on the table of the mill to make sure that the bar's horizontal, because it's the same height there as it is at the jaws of the vise. Certainly be good enough. So now it's been drilled and countersunk, so it's just been a question of turning it round and offering it up to the other end of the table, fixing it loosely in situ with the screw, and then doing the same thing with the transfer screw again at this end of the table. Okay, so that's the main bar in situ. This is it here, right along the back of the table. Now, the screw holes, the threaded holes that were on the back of the table already, there's There's only two of them, and they're only M3, and they're right at the ends, and they're very shallow. There isn't much depth, so they're held in by very short lengths of M3 thread, these two, this bar. However, you know, I certainly didn't want to be looking a gift horse in the mouth at this point, and starting to drill new holes when I haven't even tried these ones. And the bar at this point in time, despite that, it feels rock solid on the back of that table. If the screws work themselves loose over time, I might have to rethink it, but meanwhile, if it ain't broke, don't fix it. So the next bit is to look at the scale, fixing it to this bar, and also to look at the reed head, which will go in a small bar underneath, and there's already pre-drilled holes there as well. So the x-axis is going to be a lot easier than the y-axis, because firstly because it's pre-drilled, but also because this surface here at the back of the saddle is completely vertical and in line with the back of the table. So the same bar, a piece of the same bar just gets screwed straight on there, and then it makes a continuous plane. So basically the reed head will just be screwed onto that, and the bar screwed onto this, and Bob's your uncle, they're all flush with each other. So much less fiddling around and having to accommodate that sloping angled casting draft on the base casting. So shouldn't take too long, hopefully. Okay, I'm not going to counterbore these holes or countersink them in the mounting bracket for the reed head, because they're a bit too close to the edge. They're closer to the edge than I'd like them to be anyway, but well, there's another two holes higher up. I'll see if I need to use them. But these, if I try to counterboard them, it's just going to look a bit untidy. Not that it'll ever be seen, but there's no reason to really, because they won't stick out any further than the reed head will stick out further than they do, so they won't be in the way of anything. So that's pretty good. The mounting brackets for the scale and for the reed head are now both fixed onto the mill. You can see the reed head scale at the bottom has still got its blue layout die on, but it sits in there quite nicely, sort of abutting the long mounting bar for the scale. So the next thing is to fix the equipment to its mounting bars. So there's the slots in the mounting bracket for the scale. Well, they're on the scale actually, so I'm going to just drill and tap this bar here. It's M6, screws will fit through there, and that way you've got quite a bit of adjustment up and down with the slot there, which is quite handy. One nice feature of these Sieg mills, once you get away from the bottom end of the range, is this tapping mode, which basically these green buttons on the ends of the handles of the quill feet just allow you to forward and reverse the direction of the spindle, and when it taps it just pulls the quill down into the thread. I've never used it before, but I used it tonight to make the threaded holes in the mounting bar, and it was pretty straightforward. I mean, I wouldn't use it if I was tapping a cylinder head or anything like that, but I think for tapping through an aluminium bar, it's a breeze. So I was also a bit scared of it before, but I found it very pleasant to use. This is the mounting bracket for the sensor, the reed head. I assembled the whole thing and then just put a drill bit through the mounting holes in the reed head to mark out these two little holes here. It was the best way I could do it, really. Just a drill bit, and then I scratched the little holes. They're fairly clear, but I'll double check them once I've drilled one, and then tap it, and then that will be the last two holes drilled. So finally I'm just going to square off the ends of both of these bars with an end mill, take the marking blue off them using some methylated spirits type alcohol, and then reinstall them on the mill. So there are both mounting bars installed. The upper one for the scale and the lower one for the sensor. So, and there's the DRO gear installed. And here is it working. It's a good day for me. I now have effectively a DRO on all three axes of my mill, including the little one on the Z axis here. So that should enable me to do some half decent work, hopefully. And all that remains to be done now is some fine tuning with running an indicator along the scales, make sure they're as level as they can be, and then making and installing covers for them, protective covers, and that should be about it. So hopefully get started on some of that tomorrow. So the DROs need protective covers to keep oil and swarf and stuff off them, just so that it doesn't get into the works and knacker it all up. So what I've done is quite a simple solution here. I bought a length of black UPVC square section down pipe, and I cut off the appropriate lengths for the X and Y axes. And you can see the Y axis there, it's just been cut into an L-shaped profile, and the holes have been drilled and tapped. Where am I? Here, yeah. Holes have been drilled and tapped into the mounting bracket, the aluminium mounting bracket. You just see the end of there, just some holes drilled and tapped into that, and then some set screws, cap head screws to secure it in position. So it hangs over and goes down and covers the bar and the sensor. The one in the back isn't quite completed yet. It's longer, obviously, it's for the X-axis. And the cover will be fixed onto drilled and tapped holes in the mounting bracket, and then the job will be done. By the way, just another couple of small points. The holes I've just spotted there with a centre drill in hand, held in a handheld drill, and I'm just going to drill the holes freehand rather than dismantle the whole lot. I'm just going to drill them with this ordinary DIY, well, kind of reasonably good quality DIY hand drill, just because I can't be bothered taking it all apart just to do that. If you're careful, you can hold the drill straight enough for a job where the perpendicularity is not actually critical. And also another thing is that the overall height of the mounting bars plus the thickness of the black plastic plus the head of the screw will all still be lower than the top edge of the table here, just so that if anything's on the table overhanging it, it doesn't foul the screws, it will just slide over the top of them. So I've used flat sort of pan head screws for that reason. You don't want them sticking up, otherwise you just restrict your work holding capacity. So it is done. Let's take a look. See the black plastic protectors on both scales. The only glitch that I had was the second screw. I was too cocky about drilling these holes freehand, and I broke a drill bit off in the hole. Fortunately for me, the broken bit was about 3/4 of a centimetre down inside the hole, so I still had a little bit that I could thread and tap, and I just cut off the screw a little bit short so that it could go into the hole without bottoming. So it's all fine really, there's no point in re-drilling that or anything, it was just one of these things. And the only other thing is that for the bellows there, you'll see that all I've done is make a hole in the rubber and trap it under, and past that screw that mounts the protector to the mounting bar. I've put that through the rubber as well, which means that the whole thing's a little bit off centre, the bellows, but there's enough stiffness in it that it moves in and out both sides and keeps the slideways covered. And really it was either that or faffing around, you know, right in the depths of the saddle here, drilling and tapping 2 holes, and just for a bit of rubber that will go back and forward and function perfectly well anyway. I don't think so. So although that's a little bit of an unsightly imbalance, it's actually totally functional and I'm not going to worry about it. So job done, and get on with some milling. I say some milling, I mean more milling actually. These numbers are actually changing. I don't know if you can see it or not, but they are. Okay, thanks for watching and see you later.